Okay, this is the data collections methods. This is an overview kind of notes here, so I gave you those notes, those nice notes to kind of go along with. So if you have those out and you're ready to go, the first major question we talk about when we talk about data collection is why do we even collect data? Remember, the idea is basically we want to learn or gain knowledge about something important to us. That's why we collect data. It's again to learn or gain knowledge about something that's important to us. Who do we collect data from? Well, the idea is that we collect data from a population. Okay, so a population would be everybody that's interested in us. Okay, so this giant circle would represent our population. Okay, now you have to look at who you're interested in data from. If you're interested in data about high school age students, then obviously your population would be all high school age students. If you're interested, again, you got to be more specific too. If you're interested in just American high school age students, then your population would be all American high school age students. If you're talking about all high school age students, then you're talking about the population of the entire world, high school age students. Your population could simply be Twinsburg High School students if you're only interested in students about Twinsburg High School. And again, your population all depends who you're interested in data from, and that's the population. Everybody that you're interested in. Now, usually we don't collect data from the entire population. We collect data from a subset of that population known as a sample. Okay, so a sample would be part of that population. So if our population again is Twinsburg High School students, then our sample would be a sample of students from Twinsburg High School. And you don't have to focus on, oh, our sample should be X percent of the population. Like a good sample is 15% of the population. No, it has nothing to do with that. Honestly, it's just based on your sample size. And what's a big sample size? Who knows? We call our sample size N. Okay, and there's no set number for the sample size. It all depends, but don't ever look at it as an appropriate percentage of the population. So again, we collect data from a sample, and that sample is supposed to represent a population. So if we collect a sample of 15-year-olds from Twinsburg, Ohio, then that probably means we could only make our results applicable to 15-year-olds from Twinsburg, Ohio. If we make our sample a sample of high school age students from Utah, then we could probably relay our results to high school age students from all of Utah, and that would be the population. So again, it should make sense there. Okay, what do we call the data we collect? Well, let's start with our sample. Okay, when we collect data from a sample, we call the data we collect statistics. Okay, statistics come in a little too many A's there. Statistics, anyway. There's two different main statistics we look at, and the first is we look at the mean, okay, or the average. And if it's coming from a statistic, we call that X bar. Okay, so maybe we're looking at the the average weight of high school students, or maybe we're looking at the average amount of time that a high school student brushes their teeth, or maybe we're looking at the average amount of time it takes for an ambulance to respond to a 911 call. But again, we're trying to create a statistic, and that statistic comes from our sample, and one way we're looking at is a mean, the average amount of something. Again, could be a lot of different things, and I just gave you a couple of examples there. The other information, the other statistic that we get from a sample is called a proportion. Okay, a proportion is better known as a percentage. And a proportion, we use the letter P, but to represent that it's coming from a sample, we call it P hat. Now, we've used that hat before to represent predicted values. Here, it's not representing a predicted value. It's just representing a proportion from a sample. Okay, so it's something that we saw. So statistics we actually see. When I'm talking about a proportion, maybe we're talking about the percentage of people that wear a seatbelt, or the percentage of people that are going to vote for Romney in this upcoming election. Or the percentage of kids that whose parents pick out their clothes for them to wear in the morning. I don't know. We're just looking at a proportion of something. Okay, so we got the average, or we have a proportion. Now, statistics come from samples. Parameters come from the population. So when we have the population, we have what's known as parameters. Now, we never really know the parameters. The idea is we're trying to use our statistics to represent that population. So the mean from a population is mu. So again, we're trying to find the average amount of time a high school student spends brushing their teeth. Well, somewhere out there is mu, the true average amount of time that high schoolers spend brushing their teeth. Our sample is just going to show X bar, which is what we saw in our sample. And again, same thing with proportions. Somewhere out there is a true proportion of high school students that wear their seatbelt, and we call that true proportion, or again, true percentage, right? We call that P. So P would be the true proportion that's floating out there somewhere that we're never going to really know. We're just going to know what our sample says, and that would be P hat. So we got proportions and means. X bar is the mean, or mu is the mean from the population. That's the parameter. And then we got proportions, P hat coming from the statistic that we actually saw, versus P coming from the population. Again, parameters we never really know. We just use statistics to try to estimate them. Lastly here it says, can we infer our results from a sample will be the same for a population? Obviously the goal is yes. We want to be able to say, hey, my samples show that the average high schooler spends 3.4 minutes brushing their teeth, so I can infer that that is probably true for the population. Or I infer that 89% of high school students wear a seatbelt, so I'm going to hopefully be able to infer that that is the same value for the population. Of course, we'll never know for sure it is, but the idea is a sample can represent a population, so we use the word representative. Representative. Okay, so what we're looking for is that our sample is representative of the population. So if our sample represents the population, then yes, it is okay to infer our results from a sample to the population. For example, if our sample was drawn correctly from the population without any bias, and it did represent it, okay? If our population was Twinsburg High School students and our sample somehow collected some people that don't even go to school in Twinsburg, some kids that have already graduated from Twinsburg, or some elderly people, then obviously that sample wouldn't represent the population. So if our population is high school age students from Utah, then our sample needs to be high school age students from Utah so that it represents the population. As long as it's representative, then in fact we can infer results from our sample to the population. Now, there are 4 ways to collect data. Okay, they come kind of in pairs of 2. 4 ways to collect data. They kind of come in pairs. Okay, so let's list them real quick, and then we'll talk about each one of them individually. Okay, the first way to collect data is a census, and the second way to collect data is a sample survey. Now, these two are connected, okay, because we're looking for a parameter. Looking for a parameter. Now, again, a parameter is the true average or the true proportion. We're looking for that. So if we collect a census, we're looking for some true average or some true proportion. If we're looking at a sample survey, we're again looking for some true average or true proportion. We'll talk more about those in a second. The other 2 are observational study. And the 4th one is an experiment. And the idea with these two are connected because both of these are trying to estimate differences, or estimate a difference between 2 groups. Okay, so they're basically trying to look at 2 variables at a time. They're trying to show, is there a relationship between 2 variables? Okay, is there a difference between group 1 and group 2? Or does X affect Y? So that's what these are trying to show. So we're trying to observe with an observational study or an experiment, can one variable affect another? Okay, and we're trying to look at the difference between 2 groups usually with those 2 things. All right, so let's talk a little bit more specifically real quick about a census. Hopefully this won't take too long. A census, and again, you need to just write down whatever you need to, not necessarily what I write down, but what I say. the general description of a census is a way to include everybody by sampling the entire population. So in a census, we sample entire population. Okay, so we're going to sample the entire population in a census. So we're not just going to take a small sample of the population, we're going to sample everybody in the populations. Now, the pauses here is that if your population is small and you can actually get to everybody, it's like the best thing to do. Obviously, census would be best. Okay, so think about it. If you wanted to learn the average age of Twinsburg High School teachers, well, there's not that many Twinsburg High School teachers. We're talking maybe 50 to 75 teachers in the high school, and you wouldn't want to take a sample of just 5 of them. You'd look at all of them. I mean, if your population is Twinsburg High School teachers, why would you not go to all 75 of them? It would not be an impossible task to get to all 75 teachers and simply ask them their average age. Or likewise, if you want to know what percentage or what proportion of teachers are going to vote for Barack Obama in the next election, it wouldn't be impossible to get to all of them, so it makes sense. Same thing in a company. Maybe you're the owner of a small company and you only have, I don't know, 300 employees. I guess that's not really that small, but it's not enormous. 300 employees is not impossible to get to, and you want to know their average salaries. Well, you could easily get to all 300 of your employees and find out what their average salary is, or find out what their salary is, and you can take an average. So it wouldn't be impossible to do that. Or maybe you want to know what proportion of people at your company get to work on time. Well, it wouldn't be impossible to stand at the door and watch every single person and what time they come to work and whether or not they're on time or not. So in some ways, the census can be very good. Now, what are some ways a census can be bad? Well, the negatives of a census are, first off, they're oftentimes very impractical. Okay? Impractical. Meaning that it's difficult to complete a census, okay? The cost is usually expensive because it costs a lot of money to try to get to everybody. And think about it this way. Maybe you're the taste tester for the Hostess company, and the Hostess company makes Twinkies, and you're the taste tester, and you need to, they tell you, hey, you got to run a sample, or you got to run a census. You need to taste test every single Twinkie. Think about how impractical that is. First off, could you actually eat every single Twinkie? Probably not. But even if you could, then you'd have no more Twinkies left to sell because they've all been eaten by your taste tester. So it wouldn't make sense to do a census for that. You would simply sample maybe every 10th Twinkie that comes out, or one from every, one every hour, or something like that comes out of the machine. Also, think if you're a wine taster. If you have to taste a large sample or all of the wine, then you're going to become drunk, obviously, by the time you're done doing it. So it wouldn't make sense to do that. Another negative to it is oftentimes populations don't stand still. So it's not like it's easy for you to get to 1 million people because, if your population is all U.S. residents, I mean, people are constantly being born, people are constantly dying. Even if your population is all people that are of voting age, well, by the time you're done, there might be people that have turned 18 or people that have died that no longer can vote anyway. So populations don't stand still. So it's really hard to get to everybody when your population is really large. Also, a census is actually more complex than a sample, okay? And some people say, no, it's not. No, it's not. It makes more sense than a sample. Well, oftentimes one person can easily do a sample. I could go ahead and get a sample of 20 students at Twinsburg High School very easily, whereas to get a sample of all students across, the United States, you're going to have to hire a lot of people to help you out. You're going to have to spend a lot of money going around to get to all these people. So that is why there's a lot of negatives to a census as well. All right. Now let's move on to sample surveys. Okay. Now, sample survey is obviously, instead of surveying the entire population, you just create a sample. So let me read what I had here. One second. You simply collect data from a sample of people by asking them questions or getting measurements. So again, when you collect a sample of people instead of the entire population, you're going to either get an average So you're going to ask everybody their weight, you're going to ask everybody how much money they make, and then you're going to get an average for the group, or you're going to ask everybody a question and turn that into a proportion. What percentage of you guys drive a car? What percentage of the people wear a seatbelt? What percentage of you guys eat a healthy breakfast? What percentage of you guys get to work on time every day, and so forth. Okay. Some positives is that a positive is you simply don't have to survey everybody. You just have to survey everybody in your sample, so it makes it a little bit easier to do. Also, if your sample represents the population, again we talked about representative of the population, then you can simply infer your results to the population, which is nice. The negatives, though, is that you need to, a sample survey isn't as easy as you think. When you collect that sample, because it has to be representative of the population, it has to be really well thought out how you're going to collect that sample to avoid any bias, because the moment there's some potential bias in how you selected your sample, it's all of a sudden the results are useless. Just throw them out the window if there's bias. So, one of the negatives to a sample survey is that you have to take a lot of time in collecting your data appropriately without bias. Okay? All right, let's move on to the idea of an observational study. Okay? An observational study, again, in an observational study, let me write that down so you see it first. This is the third method, observational study. In an observational study, you're trying to determine, can X impact Y? Can one variable affect another? Okay? Or you're trying to see if group 1 is any different than group 2. So maybe you have a group of students that work after school every single day and a group of students that don't work every day after school, and you want to examine how their grades are. So you're examining working versus grades, but you're doing so by observing one group of students that do work and another group of students that don't work. That's obviously an easy example to understand. Now, observational, the key is that you do nothing but observe. You do not assign kids to do anything. You don't tell, hey, group 1, you guys work every day. Group 2, you don't. You simply have selected them because of something that has already occurred to them, because of a characteristic you already know about them, and then you simply observe. You do not do any kind of manipulation. You do not manipulate these groups in any way. There are two types of observational studies. The first one is retrospective. And in a retrospective observational study, you select sample, and all these definitions are in your book, by the way, if you feel more comfortable looking into there. But you select your subjects, and then you look at previous behaviors or conditions. Look at previous behaviors or conditions. So in my example of students working, what we would do is we would select a large group of students that do work and a large group of students that don't work. Again, we would not tell them what to do. We would just choose them because of the way they are. And then we would look at their past grades. So we'd say, okay, you guys have worked. What were your grades last semester while you worked? Group 2, you guys don't work after school. What were your grades last semester? Okay. And the other type of observational study is a prospective. Okay. And in a prospective, again, you select your sample. Again, you do not assign, you just select based on prior knowledge, and you look into the future. And I don't mean that you become a fortune teller. I just mean, okay, you group, you guys work every day after school. This group doesn't work every day after school. Okay, we're going to look at your grades from now for the next 9 weeks. We're going to follow your grades now. We're not going to look into your past grades. Now that we've selected you guys, we're going to look into your grades as you go here. So retrospective is looking into the past. Prospective is starting now and then looking into the future. And again, the whole idea here is you're looking at estimating the differences between two groups. A positive here is that when you do this, you could see two differences. You could actually see group 1 versus group 2, and the difference between them is they work after school, they don't work after school, so you can observe that difference. The negative here is because you're not doing any kind of manipulation or assignment, you cannot make a cause and effect relationship. So if you determine that the group that works after school has lower grades, you cannot say that the work causes lower grades. You can say, oh, I notice an association, I notice a relationship between working after school and lower grades, but you cannot make any kind of claim that they cause lower grades. Okay? Now, the last type of way to collect data is through an experiment. Okay, and just like with a observational study, we're trying to determine, is one group, so group one, are they? We're going to kind of look at them versus group two. Okay, now the difference in an experiment is who goes into group one is chosen by me. Who goes into group two is chosen by me. So if we, I mean, this would be kind of unlikely. I'm going to change the example here in a second, but if we would look at the students who work after school, not I would decide, okay, you 10 kids, you are going to get a job after school and you're going to start working. You 10 kids, you guys are not going to get a job after school and I'm going to look at your grades. All right? Another kind of form of an experiment would be if you're going to see if a new diet pill causes people to lose weight. So you're going to say, group one, you are going to take this diet pill for the next 2 months. Group two, you are not going to take this diet pill for the next 2 months. And then at the end, we're going to look at the results. Okay? Or group one, you're going to do this new exercise routine every single day. Group two, you are not going to do this new exercise routine, and we're going to see if there's any results at the end. So in the experiment, we were actually manipulating some type of factor onto the groups. Okay, and maybe you even have 3 groups. Maybe we're going to look at 3 groups, all right? I don't know. We're going to talk, obviously, a lot more about experiments, but that's the idea of what an experiment is. It's different from an observational study because you are determining what the people in group 1 are doing, and you're going to determine what the people in group 2 are going to be doing, okay? You can even do something like maybe you want to determine if a new fertilizer is better than an old fertilizer for grass. So group 1 is going to be a group of a big field of grass, and group 2 is going to be another field of grass, and group 1 we're going to put a new fertilizer on. In group 2, that field of grass, we're going to put an old fertilizer on, and we're going to compare the results. Again, we could look usually at the mean. What was the average amount of growth? You know, group 1, did they on average grow more than group 2? Or we could also look at proportions as well. With an experiment, the positives are that if it's done properly, you could actually say that X causes Y. So you can actually say that there's a cause and effect relationship. This new fertilizer will cause more growth. Not having a job after school will cause lower grades. You can make that claim if your experiment is done well. The negative to an experiment is that, boy oh boy, the planning that goes into a proper experiment is a ton. It takes a lot of work. So I guess that's the negative, is that it takes a lot of work, but if you do that work, you get the positive. And the positive is that the planning pays off, and you could actually claim that a new diet pill causes weight loss. Or let me give you one more example, a new skin repellent or a new repellent on your skin to help repel mosquitoes. So you want to determine if group 1 is better than group 2. So group 1, you 10 people are going to put this new repellent on your skin, and we're going to see if the mosquitoes attack you or not. And group 2, you guys are going to get nothing on your skin, and we're going to see if the mosquitoes attack you or not. We actually control who gets that treatment. Okay, who gets the skin repellent, who doesn't? And then after that, we could really determine if X causes Y. But there's obviously a lot more that goes into a well-done experiment, which was why it kind of makes it, you know, a little bit more complicated, but it does pay off, would be the positive of that. All right, so we'll, you know, hopefully you took some good notes on all of this. We'll come back and talk more specifically about each one of these types and look at plenty of examples.